Hello, Matthews Gatos here. Welcome to Factors of a Polynomial. Now, in the last video that we did, we talked about how to factor using product sum. In this video, I want to look at how do we factor using greatest common factor. So, for example, if I start with 8 variable tiles and 4 ones, which is really the polynomial 8x plus 4. I want to look at how many ways can I factor that? How many ways can I put this together to form a rectangle? Remember, the area of the rectangle is the polynomial, and the length and the width would therefore be the factors. So let's look at all the different ways that we could arrange it. So what I like to start with is my ones tiles, because I think that that would be the easiest place to start. So I have 4 1 tiles. So I'm going to look at all the ways I can arrange the ones tiles so that it's going to start to form a rectangle. So the first way that I could do that is I could just put them all one on top of the other like that. 1, 2, 3, 4. And then underneath it would go all 8 of my variable tiles. So let's look at this all together. Nice long rectangle here. Let's look at the dimensions. So I have 1, 2, 3, 4, 5, 6, 7, 8 x tiles plus 1, 2, 3, 4. Okay, and that measures by a width of 1. So what that means is I can factor 8x plus 4 as 1 times 8x plus 4. So that's one way. Let's see if we can come up with another way. So in this example here, I'm going to take my ones tiles, and instead of arranging them one on top of the other, I'm going to do them 2 at a time. So I'm going to arrange them 2 by 2. So there's the 4 together. And then underneath, I can take those 8 variable tiles and also arrange them 2 by 2. So let's look at what we have. We have 1, 2, 3, 4 variable tiles, 4x, 1, 2 ones plus 2, and then I have a width of 2. So my polynomial of 8x plus 4 can be, in this case, factored as 2 multiplied by 4x plus 2. Well, I think I can do one more type of factoring with this. So I've done them with my ones tiles one on top of the other. I've done them 2 by 2. Now let's look at them if I do them 4 by 1. So if I do all 4 in a row like that, and then underneath it, I would do my variable tiles in groups of 4. So in this case here, I have 2x and then just 1. And along here, I have a width of 4. So that means that my polynomial 8x plus 4 could also be factored as 4 times 2x plus 1. So you've seen 3 different ways that we could factor the polynomial 8x plus 4. Now let's talk again. What does factoring mean? Factoring means writing as a product of simpler terms. So factoring really is the inverse to multiplication. It's writing these two as simpler factors. So 4, for example, and 2x plus 1, those are simpler factors than 8x plus 4. Same thing with 2 times 4x plus 2 and so on. So what we really have to decide is which one of those is the best way to factor it. Which one of those options is the best? Well, in terms of factoring, the factor pairs that are closest in shape to a square, that's the ones that are considered fully factored. So here's the 3 different polynomials that we factored, the 3 different ways that we factored it. So if you look at those 3 diagrams, the one that is closest to a square shape is the last one that we did. It's closest to length and width being similar. So that means that 8x plus 4, these are all supposed to be 4, let me just adjust those. 8x plus 4, the best way to factor it, the fully factored way, is 4 times 2x plus 1. So we're going to take this idea, we're going to try another example. Let's say we factor 6m plus 3m squared. So I'm going to need 3 variable tiles, 3m squared, and I'm going to need 6 variable tiles, just single variable tiles. And I want to put those together like a puzzle piece, and I want to fit it into a rectangle as close as I can to a square in shape. So 3m squared, really there's only one way of arranging that. We could arrange them 3 in a row or 3 on top of each other. It's the exact same thing. So I'm just going to go 3 in a row, and then I'm going to line up my variable tiles underneath it. So lining them up just like that. Then I can put this one under here and here. It fits perfectly together as a rectangle. Now let's look at what we've done. We've done an X and a 1, 2. So this side here measures as X plus 2. And along here I have 1, 2, 3 X's. Now let's do it in terms of the m's that we started with. So 6m plus 3m squared can be factored as 3m multiplied by m plus 2. So writing the area as the polynomial and the factors as the length and width. And I can check to see if that's right just by doing the distributive property. 3m times m is 3m squared. 3m times positive 2 is 6m, and I see I get what I started with. So that is factored correctly. And it's closer in shape to a square than if I did them one on top of the other all the way down. So moving away from factoring with tiles, we need to talk about the greatest common factor. So what we're going to do is we're going to take each of the terms in the polynomial and write it in its prime factorization to find what they have in common, the greatest common factor. And then I'm going to show you how we use that to factor. So let's look at this. I have 12m cubed and 30m squared, and I want to do the greatest common factor. So I'm going to write each of my polynomials here, and I'm going to break it down to its prime factorization. So 12 is the same as 2 times 6. Well, 6 can be broken down into 2 times 3. And m cubed is just m multiplied by itself 3 times. Okay, let's do 30. So 30 is the same as 5 times 6. So I'm going to do 5 times, and I know 6 can be broken down as 2 and 3. And then m squared is m times m. So there I have the prime factorization of each one. I want to look for what they have in common. So I see a 2 and a 2. I see a 3 and a 3, an m and an m, and another m and an m. So what that means is that the greatest common factor is 2 times 3 times m, or 6m squared. That would be the greatest common factor. Well, a little tip for you when it comes to the variables. You can find the greatest common factor of the numbers either by prime factorization or just knowing your rules of multiplication, knowing your times table. But when it comes to the variables, in that last example, I wanted the greatest common factor of m cubed and m squared, and I saw that that was m squared. Well, my tip to you is the GCF of variables is the common variable to the smallest exponent. Now, doesn't that sound weird? Greatest common factor is the smallest exponent? Well, the reason is because m squared needs to be a factor of both of them. So if I chose the bigger of the two, m cubed is not a factor of m squared. So that's why I go with the smallest. Let's look at how we're going to factor without tiles. First thing we're going to do is find the GCF of all of our terms. So once you know the GCF, we're going to write it outside the brackets. So I'm going to put the GCF here. Okay, now inside the brackets, I'm going to divide the terms by the polynomial by the GCF and write whatever the result is inside the brackets. So inside the brackets is going to go my polynomial divided by my GCF. Close my brackets, and that will be the factors. Now you guys know I'm a big fan of the check, so you can always do a check using the distributive property. So I have 2 examples I want to try with you. Before we talk about the examples though, another tip here is polynomials are fully factored when there's no common factors among the terms. So with tiles, it was the ones closest in shape to a square. In terms of polynomials, I just want to make sure there's no common factors. So if you make a mistake and don't find the greatest common factor, you're going to have a factor that still has a GCF that can be taken out. So let's try this question. So first thing I'm going to do is look for the GCF. So I'm going to use my little shortcut. So I'm just going to look at the numbers, 4 and 12. What is the biggest number that goes into 4 and 12? Well, I know that's 4. Now you can use the prime factorization if it helps you. I just want to show you how to do it without it. Now let's look at my variables, m squared and m cubed. So they both have an m, And remember, the greatest common factor is the variable to the smallest exponent. So my GCF is going to be 4m squared. So I'm going to write that on the outside, and on the inside, I'm going to divide my polynomial by 4m squared. So here's what I'm going to do. I'll just do this in a different color. Now you can do this in your head, or you can do it like this. What I'm really doing is dividing each term by 4m squared. That's why I wrote it on the outside. So on the inside is actually the quotient. So 4 divided by 4 is 1. M squared divided by m squared, also 1. Plus 12 divided by 4 is 3. M cubed divided by m squared is m to the 1, because 3 take away 2 is 1. So what that tells me is that 4m squared plus 12m cubed is really factored as 4m squared, and I'm just going to write my 3m first. I like to see my variable first. 3m plus 1. Now I can do a quick check, and if you look at 3m plus 1, there's no common factor there other than 1, so I know I factored that fully. Now I can always check, and I do recommend that you check by using the distributive property. So I'm going to do my little rainbow here. 4m squared times 3m. Well, 4 times 3 is 12. M squared times m is 2 plus 1, m cubed. Plus 4m squared times 1 is just 4m squared. And see how I get what I started with? Well, that tells me that I factored it correctly. So I know that that is perfect. Okay, let's try another one. So again, we're going to look at our numbers first. So 24, 10, and 4. Just ignore the negative for right now. What's the greatest common factor? The biggest number that goes into all of those? Well, that's 2. 2 goes into all of them. Now let's look at my variables. So I have an a cubed, an a squared, and an a. So they all have a's, and I look at the smallest exponent, which is the exponent of 1. Now you can write it as an exponent of 1, but you don't have to. You can just leave it as a. And then we'll look at our d's. So we have d, d squared, and d exponent 4. So they all have d's, and the smallest exponent of all of them is 1. So that means my GCF is 2AD. So I'm going to write it on the outside, and then I'm going to factor in the inside. So let's just erase this here. And again, if it helps you to do this, you can do it this way, or you can just do it in your head as you're dividing. I like to write it out like this, just to make sure I'm doing it correctly. Okay, so here we go. 24 divided by 2 is 12. A cubed divided by a is a squared. D divided by d is 1. Plus 10 divided by 2 is 5. A squared divided by a is a. D squared divided by d is d. And then minus 4 divided by 2. A divided by a cancels, and d exponent 4 divided by d is d cubed. So that tells me that 24a cubed d plus 10a squared d squared minus 4ad exponent 4 factors as 2ad times 12a squared plus 5ad minus 2d cubed. And again, you can always check that by applying the distributive property. So factoring is really all about division. So they said, oh, here comes division. It's that guy from division. Looks like we're downsizing because division makes it smaller. So factoring polynomials, because it's all about division, is really downsizing polynomials. So I hope this video helped, and I look forward to seeing you guys for the next one.